This is Sarah Wilkinson from Humber College and the University of Guelph Humber. In this video, I'm going to cover some of the key components in chemical reactions. I'm going to talk about what activation energy is and how enzymes function to lower this. And finally, I'm going to talk a little bit about the regulation of enzymes. So just a little bit about nomenclature, that means naming things. There's a few things we usually talk about in chemical reactions. So the first term we're going to use is substrates. And what we're really talking about here is what is going into the chemical reaction. What are we combining together to make the product? What comes out of the chemical reaction? So substrates combine to become products. Most chemicals do not spontaneously occur. So most atoms or substrates, when they get together, don't just have chemical reactions. Some do, like sodium and oxygen. But most chemicals need energy to activate the substrate. So in order for the substrates to become products, energy is needed. And what we're talking about here is their activation energy. So if you look at this graph, on the y-axis is energy needed to activate substrates, to get those substrates to come together, to form a chemical reaction, so new bonds, and become products. The higher the activation energy, the more energy required to do this. Now, for some substrates, they'll never react because the activation energy is so high. Now, in our bodies, what we have is something called enzymes. So what enzymes do is they act as catalysts and reduce activation energy. So if we have an enzyme for a particular bunch of substrates, what this is going to do is it's going to lower the energy required to form products. And what this does is it speeds up chemical reactions, makes them more likely to occur. And some enzymes are so effective that they greatly reduce the activation energy. Okay, so we have very low activation energy when an enzyme is present. So if we look back at naming, okay, what we have is a substrate, okay, that can become product. And this is sped up in the presence of an enzyme, which will reduce activation energy. So as an example, we might have a substrate named adenosine triphosphate, and in the presence of an enzyme, myosin ATPase, which is present in the contractile proteins of muscle, what's going to happen is there's going to be a breakdown, or we'll call in chemical terms a hydrolysis, meaning in the presence of water, of ATP to produce adenosine diphosphate and phosphate, and this releases some energy. We'll go into this reaction later on, but the bottom line is the substrate is ATP, the products are ADP and phosphate, and the enzyme is myosin ATPase. So how enzymes work is that they're proteins, and all proteins are sequences of amino acids that are folded in very particular ways. And what this does is these folding of these certain order of amino acids form structures, and these structures become attracting to certain chemicals. And what we have described enzymes as a lock and key model, so that a particular molecule will fit within the enzyme, and only that molecule will fit there, and then another molecule will fit as part of the enzyme, and this brings them very close together. And we call these active sites. Here's an example of one substrate, so we'll just call it the purple substrate, and another substrate, the green substrate. And as you can see, the purple substrate will fit very nicely into the active site on the left, and the green will fit very nicely into the active site on the right. And what this enzyme will do is it's going to catalyze, bring together these two substrates much more easily than meeting outside and having a very high energy requirement to react. So as you can see, we're going to have the purple substrate move in, and then the green substrate move in as well. And what we're going to call this is the enzyme substrate complex, because we've got the enzyme and the substrate together, and they fit nicely in this lock and key model. So what this is going to do is it's going to create an area where a reaction can happen very easily, so not a lot of energy is required for it to happen. And when this reaction does happen, we call these the products. So the products obviously are then going to leave the enzyme, and we're left with the enzyme completely intact. It has not changed. All it's done is assist the substrates to react and become product. So one of the keys with enzymes is that they're unchanged by reactions. Okay, so they come in as they are and leave as they are. And one of my best analogies for this is the matchmaker, right? So the matchmaker can get people together, but they don't become involved in the relationships. They don't change as part of the relationship. One of the key things about enzymes in metabolic systems is that they can be regulated. That means that they can either increase or decrease the speed of their reactions. So for example, at rest, we don't want to be producing a ton of energy, or ATP. So the enzyme activity is going to be lower. When we start to run, we're going to need a higher production of ATP and of other molecules. So enzymes will be activated to produce reactions at a faster rate. And often in biological systems, inorganic phosphate becomes a key contributor to activation. And what it does essentially is change the shape of enzymes. Okay, but we're not going to go into that in detail in this video, other than to say that enzymes can change the speed at which reactions happen. So just a quick summary. Enzymes act as catalysts by reducing the activation energy in order for reactions to take place. They're proteins, and they work in a lock and key mechanism so that enzymes attract very specific substrates. So not just any substrates, very specific substrates that fit into them. They can change the speed of the reactions by themselves being activated. And one thing I didn't go into, but that's super important to remember, is that one enzyme controls one reaction. Another reaction will have a different enzyme. So within your cells, you'll have thousands of, not millions of different types of enzymes.